Oh, I have people now. Hi! I didn't have people last I looked. Ask me questions if you have them. Otherwise, I'm just sitting here grading your lab stuff. I'm in my closet, grading your lab stuff. Hi, Carrie. Welcome to my closet. The dogs were kind of rowdy, so that means I have to go to my bedroom. And then they stop being rowdy. Twinkie's sleeping outside the door of my closet. I'm sorry, I'm trying to mute that. I'm thinking I'm unsuccessful in doing so. Do you have any questions, Carrie? I see it says 9 of you are watching, but nobody's saying anything. For those of you who are doing that, I am officially your safety blanket. You're like, if I show up, I'll learn through osmosis. I am your safety blanket. We've covered a lot of this in class and answered a lot of questions, so I'm not surprised if nobody has any. But either way, I'll sit here and wait. If anybody comes up with anything. I'm drawing pictures, being silly. I hope everybody got to go to vote today. Actually, I didn't have to sit in line very long. It was really nice. Or stand in line, rather. Hey, Emily, there could be. Class is cumulative, so anything that we've done before is still up for fair game. Get it? Red's laying on my bed playing with a toy. You're ridiculous. Hi, Amanda. Benzene ring is a substituent group on a chain. It's not going to have anything on it. Yeah, so you're basically looking for wherever you're going to have a high priority group, right? So let's say I have a benzene ring with, let's put something small on it like an ethyl group and a phenol. Or, you know, no, wait, that didn't do what I wanted it to do. There we go. So if you notice, if I try and do one of those generate names for structures, it'll tell you that this is going to be an ethyl phenol, or you could name it as a 2-ethyl 1-hydroxybenzene. Okay. Now, if I have something that's kind of a longer chain, so let's say it has 8 carbons, and attached to one of those carbons is something with kind of a high priority group, like a ketone or an aldehyde. And then let's say I'm going to put a benzene ring on that. Okay. ChemSketch should name this correctly. Let's check and see. It should name this like the benzene is a substituent rather than, yeah. So you look at this and you say, well, it's a longer chain than benzene. That doesn't necessarily have to be the case, but it has to have the higher priority group on it. So in this case, the chain coming off has an aldehyde, and that has a higher priority than anything on the benzene because there's nothing on the benzene except that chain. So you would name that chain as the parent chain and the phenyl group as a substituent. If I did, let me see if I can do it this way. I'm having the worst time with my mouse tonight. Let's see if I can make it bigger if that helps. There we go. So 1, 2, 3, 4, 5. So the parent chain on that one should be pentane based, with a couple methyl groups on it and a phenyl. So the reason that that gets named as a pentanoic acid is because you're looking for whatever that higher priority group is and naming that as your parent chain. So hopefully that makes sense. Good. I'll give you guys a couple more minutes. Nobody's asking anything, and I have stuff I could be doing, so. We did not. A dehydration example is where we have, let's see, where's my Kim sketch? Dehydration, you'll look for basically in any kind of alcohol, not a phenol, but any other kind of alcohol. And then anytime you add in you'll want to add in some sort of acid, like sulfuric acid. And so anytime you do that, you're going to dehydrate. And the way you're going to dehydrate is going to follow Zaitsev's rule. So that's where, let's see. I didn't know who Tillman Matthews was. But I was like, well, they're interested in chemistry, so okay. So let's see, the two possible products we could get from dehydrating that. And you have to look at where the alpha hydrogens are. So the carbon 3 and carbon 1 both have alpha hydrogens to the hydroxyl group. And so you would get these two products as a minor and a major product. The more highly substituted one would be the butene. So that's basically what you're looking for when you're looking for a dehydrogenation. Yeah, really a strong acid's what you're going to be needing. In practice, you can use phosphoric acid. You basically need something that's not going to want to compete to do the substitution reaction. So if you did HCl, you would get a lot of the chlorine substituted byproduct. But in this class, I usually just use sulfuric acid or just generic H+. Like you couldn't toss some vinegar in there and hope for it to work. You would need something stronger than that. Is there another name for naphthalene? Nope. That is its name. I mean, I guess we can call it stinky mothball beast, but the chemical name is naphthalene, just like the chemical name for benzene is benzene. What's really bad is the PChem class, the physical chemistry class, comes in to the PChem lab after we leave, and they were using mothballs today too, or naphthalene today too. And I walked by some of them in the hallway, and I was like, "Why do you guys stink like naphthalene? Y'all smell like mothballs." But apparently they'd been using it in class all today too, so I was afraid that our naphthalene use made them smell, but it was really they were doing it in the lab. David, how do I tell which of these products is major and minor? So your major product is going to be the most inner alkene, where it's the most highly substituted or the most interior to the molecule, and the minor will be the one on the outermost or the least substituted. So if you look, the minor product here has two hydrogens on the first carbon and one hydrogen on the second. So like total of 3 hydrogens total. On the major product, there would be 2 hydrogens, so it would be considered more highly substituted. Yes, it's more stable. It basically has to do with the like the mechanism and the intermediates and things like that, but just in general, the how do I want to say that? If you think about just trends in stability, you know, we've looked at like trends of carbocation stability and stuff like that. So with alkenes, the more substituted the alkene, the more stable it is. So you can kind of look at it that way. Looking at the election results so far. Sorry, Carrie, it looks like somebody's going to win the presidency tonight. Will there be redox reactions? The only one that we did is the hydrogenation. So when you add hydrogen gas and palladium on carbon, we did that. That's a reduction reaction. Orthochloromethylbenzene or orthochlorotoluene. Yes, those would both be the same thing. And I would take either one. Also, I could ask either one, so you need to know what both of those are. Because toluene was one of the molecules I said you guys needed to know. So make sure you know that one. And phenol, benzoic acid. benzaldehyde, I think were the only ones that we did. Oh, I can't look at the election results. It just makes my palm sweat. Actually, it doesn't this time because I just looked disappointed. After my husband and I left the polls, the voting booth, we were just like, well, that sucked. Let's see. If benzene has an amine group and a methyl, we would name it as methylaniline. Yes. So you would still want to name it with the highest priority group, meaning the amine. You would still want to name it kind of as that, rather than aminotoluene, if that makes sense. And then Jackie, yeah, I mean, we've done a lot of those in your notes, so I'm not sure exactly what part of it you want, but anytime you have a benzene ring and you add in nitric acid and sulfuric acid, so HNO3 and H2SO4. Anytime you have those chemicals with a benzene ring, there we go, your product is going to be a nitrated benzene ring. And remember that the nitro group is a little bit weird because it has a positive charge on the nitrogen and a negative charge that's shared basically between the two oxygens through resonance. I know, Carrie. It reminds me of the movie Clerks. If you've ever seen that, and he's just like, I wasn't even supposed to be here today. That's kind of how I feel about the presidential election this year. It does, but that's when I said, hi David, that's when I said I would let you know if it's like a meta director or if it's going to add para or something like that. I'll let you know because we didn't cover it in class. Yeah. NO2 works. NO2 is perfectly acceptable. If you're trying to show the mechanism like we did in class, you kind of need to show it out. But if you aren't trying to show electron movement, then it doesn't matter. If you were just trying to like name the molecule, then that's perfectly fine. Having computer issue. Hold on. Keto and keto are only in hydration reactions. They're only in hydration. Well, for us, there are possibilities. There are possibilities of having them in other types of reactions, but for us, the only one we've seen it in is when you're doing a hydration of an alkyne, carbon-carbon triple bond. Oh, pardon me. All right, I'll take one more. You guys are being quiet tonight. This is weird. We don't have Patience in here making jokes, and we don't have Keely talking about how the whole world's collapsing on her. That's usually what I see when we get these. I did make the test because Dakivas had to take it this afternoon because he's having that surgery tomorrow. A more complex elimination reaction. What do you mean by more complex? I'm not sure I understand. Like we learned dehydrohalogenations and we learned dehydrations. I don't really think one of those is more complex than the other, really. Okay. So let's say we have what am I doing? So if you do an elimination on this molecule, we would need to use some sort of base, so let's use some sodium hydroxide. There are 3 possible products from that one. None of them would really be major and minor. They'd all probably happen with pretty similar frequency, but see if you can come up with all 3. Red, what are you doing? He's on my bed. He's fluffing all the pillows. Stop it. Come here. Come here, Red. You're going to tear up my... Come here, Red. You're going to tear up my sheets. Hey, Twinkie. I'm giving you a few minutes to work that one. I didn't forget about you. Twinkie. Fine. Be that way. Dogs are brats. Oh, hi. Hi. Don't step on those papers. Here, have some Twinkie. Hi, Twinkie. He's such a goofy dog. Alright. You have had sufficient time to work on your problem. I hope. So what you would get... Let me just copy and paste this because it'll be easier. Alright. So where would the double bond end up? Well, if I take off the bromine here, I'll just delete those. You had 3 total alpha hydrogens that could come off. So you could get a product there. You could get one there. And you could get one there. Now, as I said, this one isn't really, like, as far as major and minor, you know, if you have something that doesn't have a huge difference, then they're all going to be, you know, approximately equal in percentage of what gets made. So all 3 of those would be made in some capacity, but not really what you would identify as major or minor. But you can do the major and minor if you have, you know, lots of, if you have like the difference between a 2 or 3 substituted alkene. In this case, they're all tri-substituted, so they'd all have the same reasonable stability. For a long time, when I first came to campus, for whatever reason, I had a group of students that called me Dr. Manacles. And if they still say, I mean, like they're, you know, in their late 20s now, and they still call me Dr. Manacles on Facebook. It's kind of funny. Manny's just reminded me of that. It is really funny having the last name Man when, you know, like I meet people, if they've heard of Dr. Man or whatever, you know, like my students' parents, you know, like you might tell your parents or your significant other, they oftentimes don't think I'm female, I think, it's my name. And that leads some interesting first encounters with people as they stand thoroughly confused. Is that an E1 reaction? Let me look at it. Oh my gosh, why does this keep shrinking? Yes, it is, because it's a tertiary carbon that has the leaving group on it. I have a fruit fly in my closet. And a moth. All right. I'm going to go ahead and get off of here. Tomorrow I do not have, trying to think. I have to get on campus. I have a meeting that the provost called that he wants me to show up for some reason at 10 o'clock. So I'm not going to be able to make my normal 10 o'clock office hours, but I will still be able to email back and forth if you guys have questions tomorrow, or if you have questions tonight, you know, feel free to go ahead and, you know, take a picture of it or whatever and send it to me if you're having questions. Let me see. So yeah, Emily, if you have more questions on the enol and keto form, or, you know, what was the other one? Jackie, if you have a question on the mechanism for nitration, if you want me to double check it. I didn't show mechanisms on these tonight because we did so many of them in your notes. And so, you know, you can just compare them to what you have written, what you should have written down. But I'm happy to check those if you send them to me. So anyway, I'm going to log off for tonight. Finish grading your lab reports, or your lab exams, because I don't like that they've taken so long to get back to you. Oh, for the mechanism, will we show more than one step? Yes, because it's an E1, so it goes through a carbocation intermediate. All right, so I will talk to you guys tomorrow if you have questions. If not, I will see you for the exam in the afternoon. Bye-bye. Close out all my stuff.